There is a persistent and deeply uncomfortable idea living at the very center of modern physics. And the reason so many physicists struggle with it is not because the mathematics is wrong, the mathematics is flawless. The reason they struggle is because accepting it fully means surrendering something so fundamental to human experience that the mind instinctively resists. It means accepting that the river you believe you are swimming through, the river of moments flowing from past to future, is not a river at all. It is a painting. A frozen, static, four-dimensional painting in which every moment that has ever occurred and every moment that will ever occur already exists, permanently and simultaneously, locked inside a geometric structure that simply is. This is the block universe. And before we arrive at that profound and unsettling destination, we need to carefully dismantle the architecture of the misconception that makes it so hard to accept. We need to begin with time itself, and with the deeply ingrained human assumption that time is a universal background feature of reality, a single cosmic clock ticking identically and uniformly for every observer, every particle, every galaxy from one edge of the cosmos to the other. That assumption feels so obviously correct, so baked into the daily texture of human life, that questioning it seems almost absurd. But nature does not organize itself around human comfort. And the physics that emerged from the mind of Albert Einstein in the early 20th century dismantled that assumption with a mathematical precision that still sends a quiet shock through anyone who truly sits with its implications. To understand why, we need to understand what time physically is, not philosophically, not poetically, but geometrically and physically. In the framework of general relativity, time is not a separate independent entity floating above the physical universe like some external metronome. Time is woven directly into the fabric of space itself. The two are not separate categories. They are components of a single four-dimensional continuum that physicists call spacetime. Every event in the universe, every particle collision, every heartbeat, every photon absorbed by a distant star exists as a specific location in this four-dimensional geometric structure. You do not merely move through space. You trace a path through space-time, a continuous four-dimensional curve called a worldline, and the length of that worldline in the temporal direction is what your biological body experiences as the passage of time. Now here is where the geometry becomes extraordinary. That fabric of space-time is not rigid, it is not flat. It bends, warps, and curves in response to the presence of mass and energy. This is the central revelation of general relativity. A massive object like a star or a planet or a black hole does not simply sit passively in space. It physically deforms the geometric structure of space-time around it, pulling the fabric inward and downward the way a heavy steel ball distorts the surface of a stretched rubber sheet. Every dimension of space-time is affected by this curvature, and that includes the temporal dimension. Time itself is physically bent by the presence of mass. Consider the analogy of a vast and smoothly flowing river. You drift along its surface and you naturally assume that the entire river moves at one single uniform speed. The water beneath you, the water far ahead, the water near the distant bank, all of it appears to flow with the same steady mathematical rhythm, but then you look more carefully. Near the massive, heavy boulders resting on the riverbed, the water does something strange. It slows. It catches itself in deep, twisting currents. The geometry of the riverbed, distorted by those dense, heavy masses, physically alters the speed at which the water moves past any given point. The river is not uniform after all. Its flow is local. It depends on where you are relative to those massive, distorting objects beneath the surface. The universe operates in this precise, identical manner. Time is the flowing river, massive objects are the boulders, and the distortion they impose on the geometric fabric of space-time creates a phenomenon that is not a theoretical curiosity or a minor technical correction. It is a measurable, verified, physically real effect called gravitational time dilation. The deeper you are inside a gravitational well, the closer you are to a massive object whose curvature reaches down and grips the local geometry of space-time, the slower time physically flows for you relative to an observer positioned far away in the relatively flat space-time of open space. This is not an illusion created by signal delays or measurement errors. The clocks themselves, your biological clock, the atomic vibrations within every cell of your body, the electromagnetic oscillations of cesium atoms in the most precise timekeeping instruments ever constructed, all of these physical processes genuinely and measurably tick slower when they are deep inside a gravitational well. Time is not merely perceived differently, it physically runs at a different rate. An atomic clock placed at sea level and an identical atomic clock placed at the top of a tall mountain will, after a period of separation, display a measurable difference in elapsed time when brought back together. The clock at higher altitude, sitting in slightly weaker gravity, slightly farther from the center of Earth's mass, will have ticked faster. The discrepancy is real, and it accumulates. The GPS satellites orbiting Earth must account for this effect continuously, because without the relativistic corrections built into their systems, the positional errors would grow at a rate that would render the entire technology useless within hours. Now take this physical reality and carry it to its extreme. Imagine a region where the curvature of spacetime is not merely the gentle warping produced by a planet, but the catastrophic geometric folding produced by a stellar mass collapsed beyond its own Schwarzschild radius. A black hole. Near the event horizon of a sufficiently massive black hole, the gravitational time dilation becomes so extreme that an outside observer watching a clock fall toward that horizon would see the clock appear to slow to a near standstill. From the perspective of that distant observer, the infalling clock would seem to freeze at the edge of the horizon, its hands barely moving, its ticking stretched across what appears to be an infinite span of time. The geometric warping of the temporal dimension there is so severe that the relationship between the local experience of time and the experience of a distant observer becomes almost incomprehensibly stretched. This is not a science fiction scenario. This is the direct mathematical consequence of the Einstein field equations, a set of 10 interrelated tensor equations that describe with breathtaking precision how the distribution of mass and energy curves the geometry of spacetime, and how that curved geometry dictates the motion of everything within it. Those equations do not permit a universal flow of time. They forbid it. They replace it with a landscape of local temporal rates, each tied intimately to the local geometry, each real and valid for the observer experiencing it, none of them privileged above any other. But gravitational time dilation is only half of the story, and in some ways it is the more intuitive half. The second component, the one that reaches even deeper into the strangeness of nature, arises not from gravity, but from motion itself. When Einstein published his special theory of relativity in 1905, 1 decade before the full geometric framework of general relativity arrived, he demonstrated something equally disturbing. The speed of light in a vacuum is not merely a universal constant. It is a physical law so fundamental that all other aspects of space-time geometry, including the rate of time itself, must bend and adjust to preserve it. No matter how fast you are moving, no matter what direction, no matter what the velocity of the source of the light, you will always measure light traveling at the same speed relative to you. The mathematical consequence of this constraint is that time for a moving observer must run slower relative to a stationary observer. This is velocity-based time dilation described by the Lorentz factor, and its implications are profound. An observer moving at a significant fraction of the speed of light will age more slowly than a stationary observer. Their biological processes, their atomic vibrations, the ticking of every physical clock they carry, all run at a reduced rate relative to the frame of the stationary observer. This is not a perceptual distortion. It is a real asymmetry in the accumulation of proper time along two different world lines through space-time. The twin paradox illustrates this beautifully. One twin remains on Earth, the other travels at high velocity toward a distant star and returns. When they reunite, the traveling twin is genuinely, physically younger, not by perception, by biology, by atomic age, by every physical measure available. Their world lines through space-time had different lengths in the temporal direction, and the geometry of those different paths produced different amounts of elapsed proper time. The space-time interval accumulated along a faster, longer spatial path is shorter in the temporal direction. Time and space trade off against each other within the fixed geometric framework of the four-dimensional continuum. These two effects together, gravitational time dilation from mass-induced curvature and velocity-based time dilation from motion through the flat spacetime of special relativity, converge on a single, overwhelming physical conclusion. There is no universal present. There is no global cosmic now that all observers share simultaneously. The concept of a shared present moment is a local convenience, valid and meaningful, only within a small region of space-time where observers are moving slowly relative to one another and sitting in similar gravitational environments. Extend your perspective across astronomical distances, across vastly different gravitational fields or velocities, and the notion of a shared present collapses entirely. This is what physicists call the relativity of simultaneity. Two events that appear to occur at the same time for one observer will appear to occur at different times for an observer moving relative to the first. This is not a matter of which observer is correct. Both are correct within their own valid frames of reference. The geometry of spacetime simply does not support a single universal answer to the question of whether two spatially separated events are simultaneous. The answer depends on your state of motion and your position in the gravitational landscape. Simultaneity is not a feature of reality, it is a feature of perspective. And now we arrive at the idea that physicists find so deeply uncomfortable. If there is no universal present, if every observer carries their own local clock, ticking at their own local rate, if the concept of now is frame-dependent and relative, then what does that mean for the relationship between past, present, and future? The answer that falls directly and unavoidably out of the mathematics is that past, present, and future are not stages that reality moves through sequentially. They are all equally real, equally existing, equally present in the four-dimensional geometric structure of space-time. What you call the past is not gone. What you call the future is not yet to come. They are simply regions of the four-dimensional continuum located at different space-time coordinates from your current position on your world line. They are there, fixed, permanent, geometrically embedded in the fabric of reality as surely as any point in space is there, even when you are not standing on it. This is the blockuniverse, sometimes called the eternalist view of time, and it follows as a logical consequence not from speculation or philosophical preference, but from the mathematical structure of special relativity combined with the relativity of simultaneity. Here is the argument in its clean form. Imagine a person sitting beside you right now, at rest relative to you. Your present moment and their present moment coincide. You share a now. But imagine a second observer, far across the galaxy, moving relative to you at a significant velocity. Due to the relativity of simultaneity, their slice of space-time that they call now is tilted relative to yours. Their present moment, extended across the vast distances of the cosmos, cuts through space-time at a different angle, and that tilted slice intersects events that you would place firmly in your past or firmly in your future. If that distant observer is moving away from you, there now includes events that, from your perspective, have not yet happened. If they are moving toward you, there now includes events that, from your perspective, have already occurred. Neither of you is wrong. Both of you are describing a valid slice of the same four-dimensional geometric structure. But here is the implication that truly unsettles the intuition. If we take seriously the physical reality of each observer's present, if we grant that the events sitting on that distant moving observer's now are genuinely real, genuinely existing, then events in what you call your future are already real. They are already there, embedded in the geometry of space-time, waiting not to happen but simply to be encountered as you move along your world line. The block universe does not merely suggest that the future is determined. It suggests something more radical and more geometrically precise. It suggests that the future is not a territory you are about to enter. It is a region of space-time that already exists with the same ontological status as the chair you are sitting in right now. The distinction between past, present, and future is not a feature of reality. It is a feature of your position on your world line. Reality itself, the complete four-dimensional geometric structure, simply is, all of it, simultaneously, permanently. This is precisely the idea that generates such profound discomfort. Because if the block universe is correct, If all moments exist equally and permanently in the fixed geometry of spacetime, then the sensation you are experiencing right now, the sensation of time moving, of moments arising and vanishing, of standing at a flowing boundary between what was and what will be, is not a perception of an objective feature of reality. It is a product of your biological and neurological architecture. Consciousness, embedded in a particular world line, processing information in a particular direction along that world line, constructs the illusion of temporal flow, the way a motion picture projector constructs the illusion of movement from a sequence of static frames. The frames themselves do not move. The projection creates the appearance of motion. The four-dimensional structure of space-time does not flow. Consciousness moving along a world line creates the appearance of flow. The physics does not tell us why consciousness experiences time this way. It does not explain the arrow of time, the asymmetry between past and future that is so deeply embedded in human experience and in thermodynamic processes. The second law of thermodynamics, the irreversible tendency of physical systems to move from states of lower entropy to states of higher entropy, provides a physical direction for the arrow, but does not by itself tell us why we experience that direction as a flowing present rather than as a static geometric feature. That gap between the block universe and the phenomenology of temporal experience remains one of the deepest and most unresolved problems sitting at the intersection of physics, neuroscience, and the philosophy of mind. But what the physics does tell us, what it tells us with the mathematical authority of a framework that has passed every experimental test thrown at it for over a century, is that time is not what it appears to be from inside the biological experience of a human being. It is not a universal clock. It is not a shared river carrying all of us forward at the same rate. It is a dimension of a four-dimensional geometric structure, curved by mass, stretched by velocity, locally variable and frame-dependent, without a universal present or a privileged now. The moments you have lived and the moments you will live are all there, all real, all geometrically embedded in the fabric of a universe that does not flow but simply, permanently, and completely is. The mathematics does not flinch from this conclusion. The equations of general relativity, the Lorentz transformations of special relativity, the Minkowski geometry of space-time intervals, all of them point in the same direction. The universe is a four-dimensional block, and time as you feel it, as a moving present moment separating a real past from an unwritten future, is the most intimate and persistent illusion that physics has ever uncovered. Not because the experience is false in the sense of being irrelevant, but because it describes a biological encoding of a geometric reality that is far stranger, far more complete, and far more permanent than any of us were built to perceive.